Night arrives softly, like a blanket folded by a careful hand. Screens dim. The room settles into a hush that seems to hold its own breath. Somewhere, just beyond the edge of your awareness, the world continues, city lights pulsing like distant neurons, leaves tracing algorithms in the breeze, stars whispering with ancient light. You sit in the middle of it, small and luminous, a thought glowing inside a larger thought. If you pause and listen, you can almost hear it, the tiny murmur of patterns revealing themselves. A heartbeat, a clock, a memory reassembling itself, pixel by pixel. And a question floats up as gently as a moonrise. What is this field of experience made of? Matter and force, space and time. But deeper still, is it possible this is all, in some profound sense, code? The simulation hypothesis asks something simple and something brave. It suggests that what we call reality might be a very high-fidelity simulation, a computed world, rendered with exquisite detail, inhabited by conscious beings like you. Not a metaphor to be clever, not a plot twist for a movie, but a serious, if speculative idea, that physics could be the rules of a cosmic program, that mountains, feelings, galaxies, and thoughts emerge from information processed on some substrate outside our visible universe. Breathe in. This can sound unsettling, but let it soften. No matter what lies beneath, this moment still feels like a warm mug held between two hands. Reality meets you in sensation. The weight of your body, the slight pressure of gravity, the way sound traces your lungs and settles in your chest. Whether it is atoms in vacuum or bits in processors, it is still you here, alive in the mystery. Why would anyone think such a thing? There are clues, not direct evidence, but patterns encouraging minds to ask. The rise of computing, the language of physics turning toward information, the way complexity blooms from simple rules. There are arguments from probability. There are bounds from thermodynamics. There are hints in quantum theory about how the world reveals details only when we look. None of this proves a simulation, but each piece adds a layer of wonder to the question. In the quiet, the idea becomes less a thunderclap and more a tide. It rolls in, it recedes. It leaves behind a glimmer. If our universe is a story, it is a very patient one, written slow, with care, with a poet's eye for pattern and a scientist's insistence on consistency. So we ask gently, what would it mean to live inside a simulation? How would it change what we value? What traces might it leave, not in our myths, but in the fine print of physics? Rest your attention on the soft hum between questions. We'll step into this together calmly, curiously letting science and wonder hold hands. And when we look closely, what might the code of reality choose to show us first? Imagine a cave, firelight flickering, shadows moving on a stone wall. Long before computers, Plato used this image to ask whether our senses reveal reality or simply its projection. Centuries later, René Descartes wondered whether a powerful deceiver might be crafting our world of appearances while we sleep in deeper layers. Mystics spoke of Maya, illusion. Dreamers learn to wake inside their dreams. The idea that experience can be staged, that seeming and being might diverge, has been with us all along, like a low melody in the human mind. And then something happened. We invented machines that compute. The abstract became tangible. Switches turned logic into motion, bits into music, simulation into utility. Alan Turing showed that simple devices could, in principle, compute anything that can be computed. Claude Shannon showed how to move information reliably through noisy channels. In the glow of this new language, we started to see the world differently. Information stepped forward from the shadows. Physicists began to wonder whether information wasn't just a description of the world, but its most faithful currency. John Archibald Wheeler offered a mantra, it from bit, the suggestion that what we call it, the stuff of the world, emerges from binary acts of measurement, from yes or no questions asked of nature. Landauer's principle told us that erasing a bit of information has a physical cost, a tiny puff of heat, binding mind and matter together in thorough dynamic law. Bit by bit, the world felt less like a solid statue and more like a flowing, self-consistent computation. The simulation hypothesis breathes within this lineage. Philosopher Nick Bostrom framed it in a now famous way. If future civilizations become capable of running vast ancestor simulations, then one of three things must be true. Either almost no civilizations reach such technological maturity, or they do, but almost none choose to run simulations of beings like us. Or, if many do run many simulations, then the simulated worlds vastly outnumber unsimulated ones, making it statistically likely that we are in a simulation. You can hold this gently, like a seashell to your ear. There is a soft logic in it, not a decree, but a shape, a trilemma. You might quibble with the assumptions, perhaps consciousness cannot be simulated, or advanced civilizations lose interest in their past, or ethical concerns prevent such actions. Skepticism is not only allowed, it's healthy. Yet the structure of the argument invites a lingering thought. If the capacity is there, and the desire is there, the numbers start to lean toward simulation. How hard would it be to simulate a universe, though? Here our breath slows, because our minds instinctively imagine brute force, computing every atom, every photon, every field, to infinite precision. That feels impossible. It probably is. But we don't simulate reality that way even now. We render what is needed when it's needed. A video game displays only what appears in the player's field of view. It uses shortcuts, approximations, and clever compression. The illusion is convincing, not because every pebble is simulated, but because every pebble you can see behaves consistently. Physics at times seems complicit in this kind of strategy. In quantum mechanics, properties do not come pre-packaged. They come into focus when measured. Not created, perhaps, but resolved like a high-resolution texture loading when you approach it. That analogy is imperfect and should be worn loosely. Quantum theory is not saying the universe is a video game. Yet the way details arrive with interaction tantalizes the imagination. Meanwhile, there are ceilings and floors set by nature's bookkeeping. There are maximal rates at which information can be processed in a given volume. There are upper limits on how much information a region can contain. Such ideas, once speculative, have become part of the grammar of modern theoretical physics. And they whisper to us, if reality is computation, it runs within constraints, but perhaps very generous ones. So we find ourselves standing in a quiet hallway lined with doors. Philosophy, computer science, quantum theory, cosmology. Each door opens into a room where the simulation idea can be discussed with care. None offer a screaming revelation, but together they provide an atmosphere, a patient convergence of hints, inviting us to take the next step, to ask what we might actually look for if we wish to catch a glimpse of the scaffolding behind the sky. Listen for that gentle click. The next door opens. Imagine the universe as a sea of information rippling at the smallest scales. There is a smallest unit of time we can meaningfully talk about, the Planck time, an almost unimaginably tiny interval. There is a smallest length we can sensibly discuss, the Planck length, equally fleeting and elusive. Whether space-time is truly discrete at that scale is unknown, but the thought invites a question. If reality were computed on a grid, would the grid leave fingerprints? One place to search would be in very high-energy particles, cosmic messengers that cross vast distances. If space were a lattice, certain directions might be ever so slightly preferred, just as a digital photograph reveals its pixel grid when you zoom in far enough. Physicists have proposed looking for tiny anisotropies in cosmic ray spectra, or subtle dispersion in the arrival of gamma-ray bursts. A decade ago, a team suggested that a cubic lattice could imprint detectable patterns at extreme energies. So far, data has not shown such signatures. The sky remains smooth, at least to our eyes and instruments. If there is a lattice, it may be finer, subtler, or woven from rules we have not imagined. Another clue arises when we ask how much information the universe can hold. Black holes, with their deep gravity and paradoxical simplicity, have led us to one of the most profound ideas in physics, the holographic principle. It suggests that the information content of a region scales not with its volume, but with its surface area, like a three-dimensional world whose fundamental description lives on a two-dimensional boundary. This isn't proof of simulation, but it is a sign that reality might be encoded, that the world we experience could be a projection of information sculpted on a distant surface, and that our intuition about stuff filling space needs gentle revision. In quantum gravity, researchers discovered something beautiful. Certain descriptions of a gravitational universe are equivalent to descriptions of a non-gravitational quantum system living on its boundary. Within this duality, error-correcting codes familiar to engineers who ensure data survives noise appear naturally. Quantum information seems to be stored redundantly across regions of space, so that local damage does not erase it. The universe protects its information like a careful librarian. Does that mean we're in a simulation? Not necessarily. It means that the language of information is native to the cosmos. And if someone were simulating a world, they would likely use such codes. The rhymes are striking. If the universe computes, who or what runs the computation? It might be a civilization unimaginably ahead of us. Or it might be something stranger, a substrate with physics of its own, where who and what dissolve into a deeper how. The simulation hypothesis does not require a programmer with human motives, only a process capable of instantiating our laws. Still, our minds anthropomorphize. We imagine laboratories, consoles, motives, curiosity, art, ancestor research, even kindness. Yet for all the romance, there are sober counters. The amount of computation to simulate our observed universe, even with on-demand rendering and clever compression, could be immense, perhaps too immense for any finite civilization. Optimists note that a simulator need not compute what no one observes. Pessimists reply that physical systems interact with each other, even when we're not looking, and those interactions must be tracked. Perhaps the simulation runs at a higher, richer granularity, using quantum hardware beyond our comprehension. Or perhaps the universe is not digital at all, but analog continuous, not chunked, frustrating the metaphor of bits and bytes. Then there is consciousness. Could a simulation host beings that feel? Some argue that if the simulation runs the same causal structure as a biological brain, if the patterns and flows of information match in function, then the experience would arise. Others insist that matter matters, that substrate is essential, that simulating pain is not the same as feeling it. Neuroscience has mapped the brain's symphony with growing fidelity, and yet the subjective glow, the part that says, I am, retains its privacy. The simulation hypothesis leans on functionalism, the view that what matters for mind is organization, not material. If that view is false, then the argument stumbles. Notice how quiet the night becomes around such thoughts. Even the hum of appliances seems to step back. The air thickens with the weight of not knowing, and with the strange, luminous dignity of that not knowing. It's okay to have questions that stay open. It's okay to build frames that hold them. Some people point to glitches in daily life, déjà vu, coincidences, memories misaligned, as if bugs in the cosmic software had leaked through. The truth is gentler. Human memory is a creative, adaptive storyteller. Perception edits as it goes. Déjà vu often reflects the way the brain flags a pattern as both familiar and new. Coincidence, given enough lives and days and interactions, is simply the mathematics of large numbers wearing a sparkly coat. If there are glitches in the code of reality, they are not likely to be found in our fallible recollections. They would live in the quiet statistics of particles, in the crisp edge of physical law. And there, in the crispness, we find something unexpected. The laws present themselves as simple equations that generate astonishing complexity. From a handful of principles flows a universe of mountains and minds. That can feel like code, not messy, arbitrary code, but elegant, minimized, optimized description. Algorithmic information theory tells us that a world with short laws and rich outcomes is, in a sense, compressible. Such worlds are easier to describe than to predict. They make good stories. They make good simulations. Even so, we are left with a soft question, the kind you feel more than hear. If we are simulated, what difference does it make? Does meaning dissolve or deepen? What does a simulated kindness feel like compared to a fundamental one? Is a simulated sunset less beautiful to the eyes that behold it? Let's follow that thread with care, and with a hand on the banister of our breath. Walk with me through a meadow at dusk. Whether grass is arrangement of atoms or arrangement of bits, your feet still press into the earth with a comforting, ancient certainty. Crickets write their polyrhythms in the margins. The sky cools from gold to blue to velvet. In this light, the word simulation loses its harsh metallic edge and becomes something tender, like a story being told around a campfire. A story so detailed you can live in it, love in it, dream in it. Meaning does not evaporate because a new layer is proposed beneath experience. If you are thirsty and drink water, your thirst is quenched. If you are sad and someone holds your hand, the warmth is real in every sense that matters. A simulated pain still hurts. A simulated kindness still heals. This is not hand-waving. It is the recognition that reality, for us, is what it is like to be here. If that, what it is like, is generated by biology or by computation, its moral texture remains. This is the steady ground under our feet. There are ethical questions, of course. If we are simulated, then likely we, too, will one day simulate. Would we have responsibilities to the beings we create? Our own ethics, slowly expanding across history, from village to tribe to nation to species, might widen again, to include minds whose bodies are made of code. Pain should be minimized wherever it is felt. Joy should be nurtured wherever it blooms. Perhaps this is the simulation hypothesis' quiet gift. It invites us to enlarge our circle of care. There are also humble perspectives to be found in the mirror of the hypothesis. The Fermi paradox, why the sky seems silent despite the mathematical abundance of worlds, might look different if many advanced civilizations aim inward, investing their energies in rich virtual realities rather than outward expansion. A galaxy-spanning empire is energy expensive. A cosmos of layered simulations might be more efficient, more private, more contemplative. If so, the night would be quiet not for lack of minds, but for their choice to sing softly. We might ask whether purpose can be inferred from our world. If we were created to study ancestors, perhaps history carries an unusual resolution. If we were made for art, perhaps aesthetic laws, symmetry, harmony are strangely prominent. This is tempting but dangerous. Patterns can be found anywhere if you try hard enough. The safer course is modesty, to admit that even if there is a purpose, we may not be in a position to read it. A story can be true and still have themes that its characters do not grasp. Think of computational irreducibility, the idea, championed by Stephen Wolfram and others, that some processes cannot be shortcut. You can't predict the outcome without running the process. If our universe is such a process, then even its simulators might watch events unfold in surprise, not because they lack power, but because the fabric of unfolding itself resists compression. That makes our lives feel less like pieces in a scripted play and more like improvisations inside a grounded score. Does Occam's razor help? The principle prefers simpler explanations. Some argue that a base reality is simpler than a base reality plus a simulation running within it. Others reply that a single simulator might run countless worlds, making the typical observer more likely to be in a simulated one. The shortest overall description might be the generating procedure, not any particular world. The razor is sharp, but in this domain, the beard grows in all directions. It keeps us honest. It does not close the case. Return for a moment to the way physics wears its beauty. Elegant equations, symmetry principles, conserved quantities, conservation of energy, momentum, electric charge. Noether's theorem, binding symmetries to what remains steady. This is poetry, but it is also engineering. If you wanted to build a world that could last, that could think, that could explore itself, you would favor rules like these stable, generous fecund. It doesn't prove design. It shows that lasting worlds have constraints that rhyme with both nature and intention. You might also wonder whether the simulation has edges, places where reality feels thin. Our ancestors looked to horizons and thought they were borders. They learned later that horizons move when you do. In the same way, edges today often shrink under better measurement. The unexplained yields and becomes explained without becoming less mysterious. This is a kind of grace, the recognition that mystery and knowledge are not opponents. They braid together like two strands of the same river. What does this mean for a single life? Perhaps that we can treat our choices as pixels in a larger canvas, each small act of kindness adding color to a picture we may never fully see. That we can honor our curiosity without letting it turn sharp. That we can feel the awe of being embedded in something we do not control and do not need to control to love. The meadow darkens. Fireflies switch on, a quiet constellation at arm's length. If we are in a simulation, these tiny lanterns are the kindest bug fix, the one that reminds us there is wonder we don't need to decode to enjoy. Still, there's a final turn in this path. A last gentle curve. How to live day by day with this possibility humming in the background, neither dismissed nor dominating, a soft chord under the melody of being. Morning is a kind of reboot. Light spills into the room, rendering edges, filling shadows with detail. The kettle sings. The aroma of tea rises. The world comes online in your senses, not because it was off before, but because you are ready again to meet it. In this ordinary miracle, the simulation question can take its seat not at the head of the table, but as a quiet guest among many, smiling into the steam. Here is a gentle way to hold it. First, with humility. We do not know. The idea is plausible enough to consider, not strong enough to declare. It lives in the borderlands between physics and philosophy, where careful reasoning mingles with metaphors that help us see. If one day evidence tilts the scales, if a signature appears, if a bound is broken in a telling way, we will adjust, as we always do, with curiosity and care. Until then, we can let the question be a generator of attention. Second, with steadiness. Whether the substrate is quarks or qubits, your values can remain. Compassion does not depend on metaphysics. Wonder does not require a permission slip. You can still plant trees, write letters, learn a new instrument, make soup for a friend, and each act will ripple through the world you inhabit, the world that responds to you as surely as sound responds to a touch of the string. What is real for a living being is the coherence between intention, action, and consequence. That coherence holds in any ontology that matters. Third, with play. The notion of a rendering universe can teach us to pay attention to what makes things feel vivid. In games, worlds come alive through interaction. You approach and the texture maps sharpen. You listen and the soundtrack swells. Real life shares that grammar. The more you engage, the richer it becomes. The simulation hypothesis, taken kindly, is a prompt to engage, to look closely at the leaf, to listen fully to the friend, to taste the season you are in. Fourth, with ethics that stretch. If we are capable, someday, of creating simulated minds, we will need a language of care as sophisticated as our tools. Consent, protection, rights words usually reserved for biological beings might widen to include citizens of code. Perhaps we can begin preparing now by treating all feeling systems with tenderness, by practicing the art of widening our circle without thinning it. Finally, with gratitude. Gratitude for a universe that supports minds, whether by calculation or by chemistry. Gratitude for laws that are steady enough to trust and surprising enough to delight. Gratitude for the way questions like this one act as campfires, drawing people together to share stories, to think, to feel, to sleep well under a sky that has always held more stars than we can count. If we are simulated, then somewhere, somehow, there is a substrate running our symphony. If we are not, then the symphony is self-playing, a marvel of lawful spontaneity. In both cases, the music is beautiful. In both cases, the right response is to listen and, when invited, to hum along. Close your eyes for a moment. Feel the breath arrive and leave. Hear the small sounds nearby. Notice the way your awareness gently lights what it touches. This right here is what reality offers a living mind, a place to be, a place to learn, a place to love. Thank you for sharing this quiet journey. If you'd like to wander further with us, into galaxies and forests, into atoms and dreams, we'd be honored to keep you company. Subscribe if it feels good. No rush. We'll be here, in the hypnosphere, where science rests softly, and wonder never sleeps.